All right, here we go. So we're going to start geometric sequences today. We're going to shift away from arithmetics to geometrics here today. Tomorrow we will be talking about geometric series. Then you'll have a quiz to do over the weekend. And then Monday we'll talk about application problems with geometric sequences and series. And then we'll move on to infinite geometric sequences and series. And then right now I'm looking at a test the following week. So probably open it right around St. Patrick's Day and then have you do it before that Friday. So we'll give you Wednesday, Thursday, and Friday to work on that test. Okay? So just so you know, that's kind of what the tentative plan is. All right. So a geometric sequence is a sequence that has a constant ratio between consecutive terms. So that constant ratio is what you use to find the next term. Okay? So basically what you're doing is you are multiplying to get the next term. Okay? We're multiplying to get the next term. That constant ratio, we call it R. Actually, you'll have an R value now for, instead of a D value, a common difference, you'll have a ratio, is any term divided by the previous term. Okay? So the third term divided by the second term is R. Same as the fifth term divided by the fourth term. Same as the 97th term divided by the 96th term. That R value has to be the same all the way through in order to make it be a geometric sequence. In more mathematical terms, G sub n, side note, we're switching from A sub n to G sub n now, because now we're talking geometric. So any term divided by the term right before it, or same way of saying it, but that's the more mathematical way of saying it. Okay? So if you're given a list of terms, or a sequence, if you will, the first thing that you should look for is you should look to see if it's arithmetic or not. And if it's arithmetic, we would add that same term every single time. Whoop, I forgot to put the old phone on the old silent. We would look and we would see, okay, so here we added 2, but here we added 4. So it is not arithmetic there. But I can multiply by 2, multiply by 2, and multiply by 2, and multiply by 2. So this one is geometric because we're always multiplying by 2. sometimes it might not be the easiest to figure out what your R value is, but you can always take any term and divide it by the term right before it, and then reduce that fraction. This fraction reduces down to 1/2. Okay. Unfortunately, you are going to want, I hate to break it to you, but you want to leave your answers and everything in fraction form. Okay? Decimals are not your friends in geometric sequences and series. Okay? Because you'll get wrong answers if you round. Okay? So if this is true, we would have to check for all of them. So 100 divided by 200 is 1/2, yes. 50 divided by 100 is 1/2. 25 divided by 50 is 1/2. 12.5 divided by 25 is 1/2. So since those are all 1/2, this is a geometric sequence with R being 1/2. I know right from the start that this sequence, this third sequence, is not arithmetic because it goes positive, negative, positive, negative. Okay. So I know right from the start it's not arithmetic. So I can find my R value by taking any term and dividing it by the term right before it, and that would give me -2. So here I would have to multiply by -2. Yes, that works. Here I would have to multiply by -2. Yes, -6 times -2 is +12. Times -2 is -24. Times -2 is +48. So this is geometric. With an R value of -2. R can be anything. Okay? R just can't be 0, and R just can't be 1. Otherwise, R can be anything. Love it. So, here is the rule. There is the rule. Okay? Any term, or the last term in a geometric sequence, is equal to the first term times your R value to the n-1 power. And I'm actually going to have you add something in here. I would like you, oops, not there, tap the brakes. I would like you to always put your R in a set of parentheses. Guess I can't move the dot. Because then if R is positive, you're fine. If R is a fraction, you're still fine. And if R is negative, you're fine. Okay? So always put that R value in a set of parentheses. So when we're doing this, we have two needs, two must-haves. The first term and R. That's all we need to find, two things. Okay. How we go about finding them is determined by what we are given in that particular problem. Okay. So for instance, if I am given the first few terms of a geometric sequence, and it is told to me that it's a geometric sequence, so I don't need to check to see if it is one or not. Okay? The first term would be the very first number. I would find my R value by taking any term and dividing it by the term right before it. So in this particular sequence, the R value is 2. That's all I need to go out and write my rule. So G sub n is going to equal my first term, 4, times my R value of 2 to the n minus 1 power. And that, ladies and gentlemen, is the rule for this sequence. The directions went on to say, then use your rule to find the 7th term. Well, that's going to be just like we were doing before, where now I'm going to find G sub 7 . So I'm going to plug 7 in for n in my rule. The only downfall with geometric sequences in series is that our terms get really big or really small really fast. Okay? So sometimes we're going to have huge numbers, sometimes we're going to have really small numbers. So this is 4 times 2 to the 6th power. 7 minus 1 is 6. 2 to the 6th power is 64. 4 times 64 is 256. So the 7th term in this geometric sequence is 256. Okay? With that being said, what I would like you to do now is I would like you to do the same thing, but on sequence B.
No, I got it.
Brady, you didn't even do it.
You guys would be so done for if I tried.
Wouldn't R be 1/4?
No, it would not.
No. Oh, I got it. Is R 3/4?
So we're going to take any term,
Is that right?
No, I picked up.
and we're going to divide it by the term right before it. Brady, since you didn't understand this problem, you should probably pay attention now.
No, Brady got it right, actually. It is.
See? Yes!
Did you say 3/4?
Yeah. Going in.
Is it
But you only did one thing.
Yeah, but I did one thing better than 0.
Mr. Lake,
What's up?
It's 3/4, right?
It is 3/4 because the 8
Right.
crosses out or 2 crosses out in the 4 there, so my R value is 3/4.
Okay, so when you have the G of 7 or whatever.
Hold on, we're not there yet. We gotta get the rule first.
I already got that though.
Okay? So my rule then is 2/3, because that's my first term, times 3/4 to the n minus 1 power. Now you can ask your question.
Okay, so when you multiply them, you multiply across, right?
Sure. Yep.
So I have 6 over 12.
Whoa.
What do you mean, well? 2 times 3 is 6, 3 times 4 is 12, right?
But the 3/4 is in a set of parentheses.
I can't.
You want to drop.
Right?
And this is why I'm struggling.
And not only is it in a set of parentheses, but it's in a set of parentheses with an exponent that's controlling the parentheses.
So, okay, so the exponent, do you multiply 6 by 3 and 6 by 4?
Okay, would that be, so, should that work?
I don't know, that's why I'm asking.
Will you
That
tell
was
me?
Because that was my question, because it was my question when I had the 6 over 12, because it still pertains to this, it's still the same thing.
Let's do the problem. Don't know.
Yeah. Okay,
Well, that's not how I remember. Hold on, let me take a note of
when
that.
you're trying, just when I'm trying.
This shall be noted.
I get the 7th term is 243 over 2,048. Again, numbers get real big real fast when you're dealing with geometrics.
When did it basically reduce it?
It's reduced to 243 over.
That's reduced.
That's reduced.
That's a big reduction.
Yeah. So if you're given one term and the common ratio, then we take the term that we're given and we utilize it with our rule. So this is basically saying that -16 is equal to my first term times my R value. I know my R value is 2 to the 6 minus 1 power. Because that is -16 is the 6th term.
You're solving for the first time.
Because we need the first term and we need R, right? Yeah. Well, what's 6 minus 1? 5. What's 2 to the 5th power? So you got 32. So this is -16 equals 32 times my first term. Divide, and I get 1/2. Negative though, right? Now I have the first term. I have R, so I can go through and I can write my rule. G sub n is equal to -1/2 times 2 to the n minus 1 power. You try letter D. 4 minus 1. 4 minus 1 is 3. Negative 3 cubed is negative 3 times negative 3, which is positive 9, times negative 3, which is negative 27. Divide both sides by negative 27. Just like over here, we divided by 32. That gives me, well, both 12 and 27 can be divisible by 3. So that gives me negative 4/9 as my first term. So my rule then would be negative 4/9 times my R value, which is negative 3, to the n minus 1 power. Okay. Questions, comments, concerns, clarification? No? Next one, you'll be given 2 terms. So if you're given 2 terms, you have to make an equation out of each one. Just like when we were dealing with arithmetics a week ago, we make an equation out of each one. So this would tell me that I would have 48 equals my first term times my R value to the 4 minus 1 power. Well, that's just 48 equals then I do the same for the other term. So I get 1036 is equal to the first term times R to the 8th power. For now. Now what you're going to want to do is you're going to want to take whichever equation has the smaller exponent. In this case, it's the green equation. And you are going to solve that equation for G sub 1. So that would be 48 divided by R cubed is G sub 1. Now you're going to take that and you're going to substitute it into your other equation in place of G sub 1. What can you do with the purple blueness of that equation? Yes, ma'am. What do you mean multiply? It's already out of the division. The 48, not yet. We will. What can I do with purple blue?
Oh,
How?
you got some
What the R's simplify to be?
yeah.
What do the R's simplify to be? You got you? Wouldn't it just be R to the fifth?
Yeah.
Right? Because I got 8 R's on top, right? And 3 on the bottom. So wouldn't that just be that?
So I was like, how do we train? I was trying it.
Yeah, I don't get it.
You just multiply the divisions.
So if we multiply this out, it would be 48 R to the 8th over R cubed. And you got 8 R's on top and 3 R's on the bottom, which means you've got 5 more R's on top. We've actually done this year. It was way back in it was one of our first units where we talked about the exponent. Yes, ma'am. Okay. Now what? Divide what? Divide both sides by 48. You still would have to simplify it. 1,536 divided by 48. 32? Fifth rooted? Yep, it is just fifth rooted.
Okay.
Yep. That rooted?
Yeah.
Yep. That's just the fifth root. What's the fifth root of 32? What? 2. Yep. Not the original equation. The highlighted one right here.
Oh.
Yep. So now you got 48 divided by 2 cubed. And that's going to be my first term, which we could have put it back in either one of them. You know, we could have went back to the original if you want. But this one's already solved for what we're looking for. Okay? 2 cubed. 8. 48 divided by 8. 6. And those are the two values that we need, right? So our rule here for this one is G sub n equals 6 times 2 to the n minus 1. Okay? Now, there is a special case when you're dealing with geometric sequences in series. Yeah? So much the same problem that we just had. Yeah? It's done exactly the same way. Yeah? So again, we set up our first equation. So our first equation would be 48 is equal to, actually I feel like this should have been green. Yep, see, green. So this equation would have been 48 equals my first term times r to the 4 minus 1 power, but I'm okay if we just write 3 there. I think it's 4 minus 1. We can subtract 1. Yeah. This one would be 3072 equals g sub 1 times r to the 9. Green or purple, which one has the smaller exponent? Green. So we're going to solve the green one for g sub 1. We're going to take that and we're going to plug it into purple. Right side of that equation becomes r to the 6th power. Divide both sides by 48. $64. Now what? Sixth root both sides. What is the 6th root of 64? What is the 6th root?
So we're gonna put a fraction.
What is the 6th root?
64.
Or 64, excuse me.
I'm trying to say the answer rather than you just take the credit. I gotta make this my half. Gotta answer the questions.
We're digging back deep into all of our mathematics vaults today.
It's just unsolvable.
No?
Oh, God, that's always a good guess, though. Class. Oh.
Even roots mean plus or minus. No? Well, the 6th root of 64 is 2.
Oh.
See, I said that.
No, you didn't. Okay? So the 6th root of 64 is plus or minus 2.
Yeah,
No, but didn't you say it was two?
I said it was two, but I took Rick's answer.
Oh.
So now you got to go back and find G sub 1 first with positive 2. So if you do that, you get 48 over positive 2 cubed. Positive 2 cubed is 8. So this is 48 divided by 8, which is 6. Then you have to go back and do it with negative 2. Because negative 2 cubed is negative 8. Which gives me a first term of negative 6. So this special case, anytime you take an even root, that's going to produce 2 rules. And both rules would work given the 2 terms that we were given.
Could you write
No. Because if you switch them around, if you had positive 6 with a negative 2 as your R value, then it doesn't work out. You know what I
Can you
mean?
do it for any other special case, or does it have to be?
You got to write them out separately.
So the negatives always go with the negative?
Not necessarily,
So how do you know which ones go together?
because this one we tried positive 2 as our R value, and it gave me positive 6. You have to plug it back in.
But how do you know you're getting the right answer when you plug it in?
Because I'm hoping that you can do this math right.
Yeah, but if,
You know what I mean?
yeah.
It's like if this term up here would have been negative 48, then this would have been negative 6 and this would have been positive 6. Even with the, you know what I mean? Yeah. You just got to plug it back in.
Yeah.
Yep. Okay? So, with that being said, those of you that didn't turn in your formative yet, and there are 29 of you that have yet to turn in that formative, technically it's not due until this evening. That should be your priority number 1. Priority number 2 would be the worksheet that you have. Now, unfortunately, the program that I use to make my worksheets still uses A for even though these should be G's, but you should be able to do numbers 1, 2, 3, and 4 now also, along with having 9, 10, and 11 already done for your learning pleasure. And then this weekend there will be a summative quiz. That will be a one-shot deal this weekend. Quiz coming up this weekend. It says so right there. Quiz coming up this weekend.
Well, no,
Summative.
I know that, but like earlier, I thought you said
There will be another one next weekend, yes.